Hello everyone. Here we will look at the problem Hamiltonian circuit is existing in the given graph or not using backtracking method. In the given graph, for finding the edges between two vertices, we will use the adjacency matrix. So here we are having the six vertices until f. So f number of vertices versus f number of vertices. So if there is edge available a to b, then we will make as 1. If there is no edge between the a to e, so there is no edge to the e, so we are making as a 0. So we will find out the adjacency matrix like this. Then we will start the algorithm with starting vertex as a arbitrary vertex. You can start from the b or a or e, anywhere. So here wherever you are starting from the vertex, that vertex will be assumed as a root of that state space tree. Now the first element whichever you are starting from the vertex, that will be the candidate solution, that is partial solution of your Hamiltonian cycle. Then we have to find out the adjacent vertex by using the adjacency matrix. Is there any edge available or not? If there is more than two or three vertices edges available, you look at that. For a we are having three edges, then we can select the next adjacent vertex as alphabet wise. So here b c d, three vertices available, adjacent vertices. So from this, b is the immediate alphabet, so we will start the next vertex as a b from the a. So like that we can extend the path from starting vertex. If we are not finding any solution through that path, then that denotes a dead end is reached. So that means if cycle is formed, look at that. If you form the cycle a b c again a, okay, a b c again a. So if you form the cycle like this means a dead end, because we didn't visit all other vertices in the given graph. So if any cycle formed without visiting all the vertices, then that means the dead end is reached. So at this case we have to apply the backtracking. If you form this cycle, then it is the dead end, so you have to apply the backtracking. Then we have to find another path from the c, then you can go to d, right? So like that we can apply the backtracking, then again initialize the searching approach. So here we will find the partial solution whenever we are reaching the next adjacent vertex. So but here if you are not getting any partial solution through that vertex, then we have to remove that particular vertex from the Hamiltonian cycle by using backtracking method. Now we will see the problem solution. Here the starting vertex is, here we can take as a. So a is having three adjacent vertices b c d. Now the partial solution of this Hamiltonian cycle is here a. Now from these three adjacent vertices, we will select the vertex b as a next adjacent vertex as per the alphabetical order. Now the possibility of the adjacent vertices are b c d. Among this I am going to select b. Now for b we are having three adjacent vertex a, c and e. So from this, a is already visited, no need to visit again. So c and e are the choices. From the c and e, here from the c and e alphabet, as per the alphabet order, we are going to select the c. So now we are going to select the c as a adjacent vertex. Now the c is going to be explore. So for exploring the c, we are having four adjacent vertices. One is a, b, e and d. So a and b are already visited. So unvisited vertices are e and d. So in the e and d, we are here d is the first vertex as per alphabet order. So now as per this, we are going to select the next adjacent vertex as the d for the c. So this is the given graph. after exploring the C. So C is having two possibilities, D and E. So among this, we are going to select the D. Now, the D is the vertex as per the previous step. So now D is having four choices. So in this four choices, A and C are already visited, unvisited are E and F. So among the E and F, E is the first alphabet order. So here D is having two possibilities, E and F. So in this E and F, so we are going to explore the node E as per the alphabet order. So here E is having uh, four possibilities, B, C, D, F. But here B, C, D is already visited, only F is not visited. So as per this, now we are going to select the F. So here from the E, when you are exploring, only F is selected. So from the F, right, again you look at that all the nodes are visited, we have to find the path to again to the A. So from the F, we have to identify path to A. So there is no path for the A. So that means this path is reaching the dead end. If it is reaching the dead end, we have to apply the backtracking method. We have to go back to the previous step. So now we have to remove the vertex F from the partial solution. So as per this, now here F is removed. Then if you are removing the F, so from the E we had only one solution, that is the F. So now we are again going back to the backtracking. So now we reached the D. So from the D, two choices are there, one is E and another one is F. E reached the dead end, so another possibility is here F. Okay, so now from the F, here we have to identify again, is there any possibility or not. So here from the D, F is there. So from the F again we are having two possibilities, one is the D and E. So here D is already visited. Okay, look at that, D is already visited. So another possibility is E. So now we have to select E as a vertex from the F. So now from the F, E is the vertex, right? So you look at that from the F, D and E. So when you are selecting that here, from the D, again what are the unvisited vertex. So from the D, you look at that E is the there, E is the unvisited vertex, but it is reached the dead end. So here D is already visited here, so it is also reached dead end. So this is also not giving you the solution. So what we have to do, we have to apply the backtracking one step. So here we have to go backtracking. So this path is not possible, so we have to select another path, this one C to E. So here from the C to E, what are the possibilities. So E is having what are the adjacent vertex. So E is having four possibilities, but B and C already visited. A also, A is not having path. Now we are going to select D and E. As per the alphabet order, we are going to select the D, right? So when you are selecting the D, E to D, right? So the adjacent vertex here, is it giving the solution or not? The path E to D here already it reached the dead end. You look at that, E to D it reached the dead end. So another possibility is here F. So from the F here is what are the possibilities? From the F again we are having D and E. So in the D and E here F is having D and E. So E is already visited, right? So now as per the alphabetic order we are getting the D. So from the D, now we are having only one possibility, four possibilities are there. Among the four possibilities, C already visited here, E already visited here, and F is visited here. So now the one possibility is A. So from the D, so again you can go for A. So from the D you are going to A. So now you look at that, all the vertices are visited: A, B, C, E, F, D. All vertices are visited. Again, nth vertex is here, starting vertex A. So here it reached the again starting vertex after visiting all the vertices. So it forms the cycle. So this cycle is Hamiltonian cycle. Now the time complexity is here. We are starting with first vertex and n minus 1, and again we are up, there is the possibility of backtracking. So it is leading into the n power n number of vertices, and power n power of vertices. So this order of n power n can be expressed in the form of order of n factorial. So this is exponential time complexity based algorithm. Thanks for watching.